Hey, calculus. So welcome to episode 2 of Math with Cruzy over Thanksgiving break. So I'm going to go over page 2 today. Some of them are review questions. Some of them are kind of like the things that we did on Thursday before we went on break. The nice thing is on number 5, you don't know how to do that because it talks about total distance. That's in our physics unit, which we will be doing in January, so you can ignore that. Okay, so yay, no number 5. Okay, so let's look at number 6. This is actually an old question. Okay, so that might pop up on your test, so let's look at it. It says the integral from 0 to 6 of f of x is 9. The integral from 3 to 6 of that same function is 5. So maybe we can draw that out right here. So this is your function f. It says from 0 to 6. So that whole thing from beginning to end equals 9. So the area under the curve there is 9. But then just from 3 to 6, this little guy right here is 5. So we can deduce from this that this has to be 4 because 4 plus 5 is going to give you 9, okay? And then they just tell you that here the integral from 3 to 0 of g is -7. If I flip those boundaries around, 0 to 3 of g of x, that's just going to equal +7. Okay, so always make sure the smaller number is on the bottom. Okay, now what are they asking you to find here? They're asking you to find this mess, 0 to 3 of 1/2 f of x minus 3 times g of x. Because I have two different functions, I'm going to go ahead and split them. So I'm going to rewrite this as the integral from 0 to 3. I'm going to go ahead and pull out that 1/2 of f of x minus the integral from 0 to 3 of g of x. And then I'm just going to find them and plug them in. So what's the integral from 0 to 3 of f of x? Well, it's this guy. We found out that was 4. So I'm going to write 1/2 of 4. And then minus, and then what's the integral from 0 to 3 of g of x? Well, they told me right here the integral from 0 to 3 of g of x is 7. So this is minus, I forgot to pull out the 3. Oh my gosh, you guys, let's pull that out. Minus 3 times 7. So half of 4 is 2. 2 minus 21 is -19, which is B. Okay? All right, now these guys, this was very similar to number 2 from yesterday. So if you want to try it by yourself, that would be great. Okay, so you have the integral from 1 to 3 of f of 2x dx equals what? Well, let's go ahead and do u sub here. So if your u equals 2x, that means your du is going to be 2 dx. So if I do this integral, I'm going to get f of u. The dx is going to become my du, but then I have this leftover 2, so I have to multiply by 1/2. Now remember, don't forget to change your boundaries on this. When x equals 3, I'm going to have 2 times 3, so my upper bound is going to be 6. And when x equals 1, I'm going to have 2 times 1, so my lower bound is going to be 2. Okay, now I need to figure out what the heck this equals. So the question is, what is the integral of f of u du? Okay, and don't worry about it being a u. It could be an x, it could be a w, whatever. The variable is completely irrelevant. Okay, so one way to get that is if I integrated both of these guys. Okay, the integral of a derivative cancels out. So this is big F of x equals the integral of little f. So I actually kind of found it. What's the integral of little f? Well, the integral of little f is big F. It just says right there. Okay, so I have big F of x, and then I'm evaluating that from 2 to 6. So if I plug this in, I'm going to have 1/2 f of 6 minus 1/2, if I plug in the 2, f of 2. So this looks like the answer is going to be E. Okay? All right, let's look at number 90, which comes right after 7, obviously. We haven't fixed this yet, sorry. Okay, number 90. So on this, again, I would do another u sub. So I have this f of 2x. So let's go ahead and do u substitution and say let's u equal 2x. That means your du is going to equal 2 dx. So when I do my substitution, I'm going to get the f of u, and then the dx is going to become my du. And then again, I have this leftover 2, which is a 1/2. Now let's change our boundaries again. So if x equals 12, I'm going to get 2 times 12. My upper bound is 24. And if x equals 6, 2 times 6, that's going to be a lower bound of 12. So right off the bat, I know that these guys cannot be right because they have the wrong boundaries. Okay, but what does all this equal? It says it equals 10. How do I get rid of the 1/2 in front? Let's go ahead and multiply by 2. So now I have the integral from 12 to 24 of f of u du equals 20. Okay, now does it matter that this, so this answer is going to be B, right? Does it matter that this is a t and this is a u? No, they did a t substitution instead of a u substitution. It doesn't really matter. Okay, so this is where I'm going to end today on page 2, but yesterday, if you watched my video, I gave you guys a couple problems in the back that I said that were good practice. If you did them, let's see if you did them right. So I'll do them with you guys all the way here. Okay, so there was number 35. So let's go ahead and do it, see what we get. Let me erase this so it looks a little bit cleaner. Okay, so this is just a basic u sub question. So if your u equals the bottom there, the x squared plus 2x, that means that your du is going to be 2x plus 2. Ooh, I love this question. It's actually kind of cute. Okay, so let's see if we do the substitution here. So I'm going to have the integral. Okay, on the bottom, I have that x squared plus 2x, so all of this became your u. Okay, and then, I forgot my dx, sorry. And then what I have here, look what I have left over. I have x plus 1 dx, but you guys, if I look at this, that does not say x plus 1 dx. So can I make it say an x plus 1 dx? Can you think of a way that I could do that? How about if I factor out a 2? 2 times x plus 1 dx. Okay, now I actually see that I have this x plus 1 dx that matches what I need exactly, right? So the x plus 1 dx is going to become my du, but I have this leftover 2, which means I have to multiply by 1/2 on the outside. And then I still have this 1 on top, right? Okay, let's change those boundaries. If I plug in x equals 2, that's going to give me 2 squared plus 2 times 2. So that's 4 plus 4 with an upper bound of 8. And on the bottom, if I plug in a 1, I'm going to have 1 squared plus 2 times 1, which is 1 plus 2, which gives me a lower bound of 3. Okay, and you guys look, I'm seeing these 8s and 3s, so that's probably right. Okay, now I have, don't forget this 1/2 on the outside. I have a 1/2. The integral of 1 over u is the ln of absolute value of u, evaluated from 3 to 8. If I plug that in, I'm going to have 1/2, and then ln of 8 minus ln of 3. Notice I'm dropping those absolute value signs because those numbers are positive, so it doesn't really matter. So you guys, what is this going to be? This looks like it's going to be b, okay? Instead of doing 1/2 times all that, they just divided it by 2, which is the same thing. All right, hope you got that right. Kind of tricky. All right, number 36. Let's do a u sub on this guy. So what do you think your u is going to be? I think it's that 3x squared plus 5, the disgusting thing inside the square root. Okay, your du is going to be 6x dx. Ooh, no boundaries. That makes life a little bit easier. Okay, so this is going to be the integral of, on the bottom, I'm going to have the square root of u. And then let's see what I have on the top that's left over. I still need to find this x dx, and there it is right there. X dx is going to become my du. It's going to be a 1 on top left over. And then the 6, I need to get rid of that, so I need to multiply by 1/6. Okay? Now, how do I integrate something like this? This is old integration techniques. I can rewrite the square root of u as u to the 1/2, and if I bring it to the top, it's going to be u to the negative 1/2 du, which is going to give me 1/6, and then u to the, if I add 1, negative 1/2 plus 1 is positive 1/2. Then if I divide by 1/2, it's the same as multiplying by 2. So this is really 2 over 6, which is 1/3 u to the 1/2. And what was the u to begin with? The u was this 3x squared plus 5. So I can write this as 1/3 3x squared plus 5 to the 1/2 plus c. Okay, and that looks like the answer is 1/3 3x squared plus 5 to the 1/2 plus c. It looks like the answer is D. Okay. All right, let's look at 38. I think that's the last one that I told you to kind of practice on. So this guy, another u sub. Let's let the u equal this x squared plus 1. And then your du is going to be 2x dx. boundaries this time, so I'm going to change those. So the u becomes the x squared plus 1. And then what do I have left over? I have this x dx left over, which is right there. So that becomes my du. 1 on top. I have a leftover 2, so I need to multiply by 1/2. Okay, let's change those boundaries. So if x equals 3, this is going to be 3 squared plus 1. That's 9 plus 1, which is the upper bound of 10. And if x equals 2, I'm going to get 2 squared plus 1, which is 4 plus 1 with a lower bound of 5. Okay, so doing this, I'm going to have 1/2. The integral of 1 over u is ln of absolute value of u, evaluated from 5 to 10. And then if I plug that in, I'm going to get 1/2 ln of 10 minus 1/2 ln of 5. And if I look at this, it looks like they factored the 1/2 out of both. So let's go ahead and do that. So this is 1/2 ln of 10 minus ln of 5. Okay, I still don't see that, but I can use my little rules, right? This is really 1/2 the ln of, remember when you're subtracting, you can divide these two. So it's 10 over 5, which is really 1/2 the ln of 10 divided by 5 is 2. Okay, so this would be 1/2 ln of 2, where your answer is B. Okay, now look, if you want some other problems to practice, how about, what's a good one you guys could do here? We did all these. How about you guys find the average value? So let's maybe try to do number 34. Remember, the formula for this is 1 over b minus a integral from a to b of f of x dx. Okay, so something old that you've done before, but you're going to have to do u sub to integrate it. So try number 34 by yourself. And then let's do a couple more integrals. Maybe you guys can integrate like number 32. And maybe you could do like number 30. Okay, you don't know how to do 31 yet. Okay, so try number 30, 32, and 34. All right, and I'll talk to you guys tomorrow.